So we're picking up from, with question number 13 on our Algebra 2, Test 1 through 50 review. Question number 13 comes from Lesson 23, Factoring Polynomials. So we're going to look at this. I'm actually going to pull up a different page. So if you'll hold on to that information, what I'm going to do is I'm going to pull up this guy right here, because I want to be able to write that equation down. I just didn't have enough room. Actually, I think I've got it right here, so I'm going to write it. We have h equals 40t minus 5t squared, and that's what we're working with. Right? They do give me a bunch of information that helps kind of understand the concept behind it. The height of an arrow, I prefer thinking about this in terms of a kickball, okay? Because with an arrow isn't on the ground at zero elevation when you shoot it, right? Because you've got the bow in your hand, you've got the arrow above the ground, so it's really about chest high. And that's why I really don't like the way the question is worded, because it doesn't allow you to kind of see and understand what it's talking about. But a kickball is on the ground, right? It is at zero elevation before you kick it. And that's going to be important when we look at the two possible answers here, okay? We want to see after it's been kicked, in this case, the arrow's been shot, how many seconds will it be in the air before it returns and hits the ground? All right, and that's shown by this function here. Height, or elevation, or altitude, however you want to refer to it, is done by an equation or a function of 40 times time minus 5 times time squared. We want to find out what time equals whenever the elevation is 0. Okay? So the first thing we're going to do is we want to factor out of this as much as we possibly can. What do both terms share in common? They both share t. Okay? What else do they share in common? Okay, and our natural tendency is to make it 5, right? Because we like positive numbers. But we want to take out negatives when we can. So we can take out a negative 5t, still leave me with something inside. So if it helps, you might want to rewrite this as negative 5t squared plus 40t, because that's the standard form of how that should look, correct? And that's going to help me kind of understand this, because if I look at it like this, what is left inside that parentheses? Okay, I took out a negative 5t, so what's left? Not negative t, just t, because we want to think about this as if we were to distribute it back in. Negative 5t times t is going to be negative 5t squared times t. Okay? Now we want negative 5 times something to be 40t. Well, it would have to be a negative number, right? Because negative times a negative would be a positive. Negative what? Negative, okay, I think I've heard it in the Spanish. 8. Ocho. Okay? Alright, now what we want to do is, because we essentially have two multiplication columns, you can look at it like this if you want, and I'm going to take both of these and set them equal to what? 0. Alright, so I've got negative 5t equals 0, and I've got t minus 8 equals 0. Alright, now with this one right here, what do I do to solve for t? Divide by negative 5. Alright, what's 0 divided by negative 5? 0. Okay? And this is true because if you remember what I said, if we think about this in terms of a kickball being kicked, where is it before the time has started? It's at 0 elevation. So this is true. Okay? Now, we want to go to our other one. How do we solve t in this case? Add 8. So if I add 8, I get t equals 8. Now, this is after the ball has been kicked, right? It goes up, and it comes back down, and from our time, it was in the air for 8 seconds. This was at 0. This is 8 seconds later. Okay? This is the correct work to show for this question. Do not expect to get credit for just writing 8 seconds, right? Because we saw this question on review. Okay? You understand the work that we need to show. And so you want to go back and watch the video several times if you're struggling with it. Okay? All right. So let's erase that, so we've got room later. Like I said, if we're going too fast, don't worry about it. You can always go back and rewatch it. Okay? Let me find my review here. Let's go down to number 14. Number 14 comes from Lesson 25, Finding Measures of Central Tendency and, and Dispersion. The number of calls received by a technical support center during 18 randomly selected days is listed. We want to identify the outlier and describe how it affects the mean and standard deviation. We don't have to actually find, I believe, actually, no, they do want you to find the mean and standard deviation. No. Oh, yeah, they do. All right, real quick, let's find the outlier. 14, right? We got stuff in the 50s, we got stuff in the 70s, 60s, 50s, 70s, 50s, 80s, 80s, 70s, 60s, 60s, high 60s, 80s, 90s, 60s, 10s, right? So we're seeing 14 as an outlier. Now, for sake of time, I'm going to tell you what some of these numbers are. The outlier is 14, and the outlier in the data causes two things to happen. It causes the mean to decrease because our outlier is smaller than all the other numbers. The illustration I used in class when we were covering this is imagine, a whole set of test scores where everybody pretty much scores between, let's say, a 50 and a 90, right? That's a fairly tight grouping, but then one person scores a 4, right? Is that going to bring the average or mean up, or is it going to bring it down? Okay, imagine on the other side, everybody scores pretty much between a 10 and a 40, right? And then somebody scores 100%. That 100, is it going to bring the average up or bring it down? It's going to bring it up. So when the outlier is high, it brings the average up. When the outlier is low, it brings the average down. Do we understand that? Now, it's also going to ask how it affects the standard deviation. An outlier will always increase the standard deviation because of what standard deviation is. And this goes back to an earlier question that you're watching in video number 1. Standard deviation is the average distance of every point in the set of data from the average. Okay? So, an outlier, because we're talking about distance, an outlier is always going to increase the average distance from the point to the mean. Okay? So, in our information here, the mean without it goes from 69.4, and whenever I include the outlier, decreases to 66.3. And the standard deviation without 14 goes from 13.7, right, a very small standard deviation because we're talking about distance, right, and it's going to increase it whenever I plug 14 in to 18.6. And how to calculate standard deviation, again, is in video number 1, okay? All right, is that enough information for you guys on number 14? Do we understand standard deviation, at least in concept? Okay, we understand what the effect that outliers have. Okay, like I said, outliers always increase standard deviation. Now, whether or not they increase the mean or decrease the mean is a matter of what side of the data they exist on. Number 15 comes from lesson 26, writing the equation of a line. The cost to fill up a car with gas and get a car wash is a linear function the size of the tank. The cost to fill up a gas and car wash for 3 customers shown below. We want to write an equation for the function in slope-intercept form, then find the cost of a fill-up and car wash for the customer with a truck with a 23-gallon tank. Now, if you'll notice, they go ahead and label tank size X, and they label total cost Y. Okay? In order for us to write a slope-intercept form, we need 2 coordinates. Now, give us 3, I only need 2. Okay? The first thing I need to calculate something in slope-intercept form is first I need a slope. Okay, we calculate slope is y2 minus y1 over x2 minus x1. Slope is rise over run. All right, so what I'm going to do is we're going to do, let's do these guys right here. So I'm going to do 21.5 minus 25.1 over, okay, 10 minus 12. You guys are going to help me out here. What is 21.5 minus 25.1? Negative 3.6. And what is 10 minus 12? Negative 2. So we know we're going to get a positive answer because we're taking the negative divided by negative. What is 3.6 divided by 2? 1.8. 1.8 is my slope. Okay? So we're going to hold on to 1.8. I'm going to erase this information here again if you need it. You can always go back and rewrite that down. Okay? The next thing I'm going to use is I'm going to use point slope formula. So that is referred to as y minus y1 equals m times x minus x1. In this case, I'm only going to use one coordinate. Okay? I like the way coordinate number 1 looks. But just so that we're not leaving anybody out, let's go ahead and use our last coordinate. Okay? So we're going to do y minus 35.9 equals our slope, 1.8, which we got from right here. Okay? Times x minus x1, which is 18. Now I'm going to erase this because we're already using it. Okay? And we're going to distribute. We're going to distribute 1.8 to both of those elements. So I've got y minus 35.9 equals 1.8x. All right, what is 1.8 times negative 18? Negative 32.4. Okay, and we want to add 35.9 to that, 35.9, so we're getting everything in slope intercept form, so I should get y equals 1.8x plus what? 3.5, and we'll say 3.50. Okay, this is the equation of my line. It matches the answer key. But are we done? No, because we need to calculate something in. We need to know how much it's going to cost with a 23-gallon tank. Where am I going to substitute that information in? This x right here. So all I need to do to find cost, which is y equals 1.8 times 23 plus 3.5. Okay? What do I get there? Should be, repeat that again for me. 44.9. So it's going to cost $44.90 to fill up my 23-gallon tank. Right, and get a car wash. Okay? $6 a day. Then you go to AutoZone, or what is it, Auto Plaza in Frisco. Auto Plaza, you get the car wash, get the oil change. I don't guess you can really fill up there, but you can get upgrade on that car wash. Yeah, I always upgrade my car wash after getting my oil change, which is getting really expensive, by the way. If you're working for Auto Plaza and you're watching this video for some crazy reason, I hope you get that. I'm not a happy customer. They need to lower your oil change prices. No, who said that? This video has been sponsored by Auto Plaza. Go there for all your car wash and oil change. All right, solve the system of equations. We've got a system of we'll call it triplicate here. The best way to do this is in a matrix. All right, so you can look at this. Yes, there is a way to do this pencil paper. You can find it in Lesson 29 systems of 3 equations and 3 variables, but it is super duper time consuming. You do not have enough time to probably go through all of the rigmarole on your test. So I'm going to show you how to plug in this information so that you can do it easily. First thing we're going to do is we're going to go to second matrix. We're going to find a matrix that we want to edit. Let's edit matrix A for simplicity. Notice that I've got a 3 by 4. Okay? So we're going to go 3, enter, 4, enter. Let's see, what's my value for x there? 1. So we're going to go 1, enter. Then I got 1, enter. Then I got negative 3, enter. And negative 3, enter. You have to include the negatives. If you don't, you won't get the right answer. 3 enter on my second row, 2 enter, 1 enter, negative 26 enter. Okay? Let's see, then we've got 4 enter, negative 4 enter, and 4 enter, and negative 20 enter. Okay? Now we're going to go out. Okay? Let's see, we want to do RREF. Is that correct?
Yeah.
In order to find that, we're going to go second matrix. We're going to go to math. We're going to go down to, I think, about number B, letter B. Okay, second matrix again. We're going to select that matrix that we made, which was matrix A. I'm going to close everything up there. And my answer, because you notice that it's times an identity matrix, X will always be the number at the top, at least if I went X, Y, Z. Negative 3 is Y, negative 2 is Z. You want to be careful in these systems of equations. If they don't put a number in for one of those variables, you need to make sure you put a 0 into your matrix. Okay? So be careful with that. Sometimes they'll get you with that. All right? So negative 6, negative 3, negative 2. All right, 17. 17. All right, we got number 17 comes from lesson 31, multiplying and dividing rational expressions. You'll see a question like this show up in video number 1. Okay, I'm going to pull this guy out here and write it up on our board so we can work with it a little bit easier. We got x squared minus x minus 6 over 2x squared minus 6x. What we want to do with these is they look really complicated, they seem really complicated, but if we take them one step at a time, they are doable. All right, so what we're going to do first is we're going to simplify, we're going to factor our numerator. Okay, I can do that by making it instead of 2 sets of parentheses. Because it's x squared, what are my first things in my first slots? X and x. It's negative, negative. All right, so we might have to go back and look at some old notes to find out what operation is going to go in there. What should it be? Negative and a positive. So we're looking at things that multiply to be 6. When I add them up, I'm getting negative 1. 3 and 2, where the 3 is bigger, correct? 3 and 2. All right, so we're going to set that there. Let's go down to the bottom. What can I factor out of the bottom? You saw a problem that involved doing this earlier. We can take out a 2x. Very good. All right, that's going to leave me with an x minus what? X minus 3. Okay, now let's move on to our other one. Okay, we've got x squared plus x. Okay, let's see. X squared plus x. Can we go ahead and factor that out? What can I take out of there? I'm going to take out an x. This is the part that gets people. What's going to go inside that parentheses? X plus 1. The plus 1, people tend to lose that. Remember, we do have to be able to distribute it back in and get what we started with. All right, here across the line, we've got x squared plus 4x plus 4. So let's break that down. Okay, we should get x and x. It's plus and plus, and I keeps life easy with plus and plus. 2 and 2, because multiplying them equals 4 and adding them up equals 4. All right, now we can look at things that we would eliminate if they were in both the numerator and denominator. All right, so let's start off with x minus 3, because it exists in a denominator anywhere. Yes, here and here. Let's look at an x plus 2 up here. Does that exist in a denominator anywhere? Yes, but I do not get to take both, I only get to take one. Okay, we can come across, I don't see a 2x up top, I don't see an x plus 1 anywhere, do you? Okay, so with the rest of this, let's see if I can drag this down a little bit. Okay, let's drag it down to there and look at what we've got. So simplifying this, this is 1 over 2x plus, we can make that x squared plus x again, because it did eliminate, over x plus 2. Now what I have is 2 fractions. How do I add 2 fractions? What do I have to have? Common denominator. All right? And what do I do if the common denominator isn't obvious? multiply both sides by the other side's denominator on top and bottom. Okay? So, I can multiply this by x plus 2 over x plus 2. Is that correct? Yeah. I can multiply this by 2x over 2x. Okay? Let's try to work that out. Let's drag that guy down here. All right. X plus 2 times 1 is just going to be x plus 2. Okay. And we can go ahead and add over here. We're distributing the 2x to everything, correct? So 2x times x squared is going to be 2x cubed. Okay? And 2x times x is going to be 2x squared plus 2x squared. And really everything, let's run this guy. I think only up with x plus 1 over 2x plus 4. What if I mess this up? It's going to really be embarrassing online. There's going to be all kinds of negative comments and views. Alright, so we're going to get, let's see. I guess there was a second one. Yeah, no, they're not going to do it else. Alright, so we've got, if we're doing that, we're getting 2x squared. Let's see, plus 4x. Hey, that's somewhere. Let's try to find out where it's at. Okay, these things do happen. Okay, let's see, we should get just an x plus 1. Oh, I see. Okay, so here's where my mistake was. Is that this is all multiplication, right? So this x and this x will cancel out. So forget about all of that malarkey down there. Okay? What we're going to get is x plus 1 over 2 times x plus 2. Or you could say x plus 1 over 2x plus 4. Okay? Either one of those right too. Double check that again. X plus 1 over 2x plus 4 is what they're looking for. I apologize for the confusion. He is in fact human, folks. I know that there were doubts. Some thought he was a machine. Others thought he was just something more. We believe it's just like the rest of us. All right, number 18. Number 18. Determine if y equals 4 is vertical or horizontal main graph. Folks, what type of line is y equals? Horizontal. And we just, if we go graph it, we get 1, 2, 3, 4. And then we have our horizontal line coming across just like that. That's the graph. And it's a function. And it is a function because it does pass the vertical line test. Huzzah! Success. The line is horizontal. Okay? Number 19. No way I'm going to get through every single question. At least not in 2 videos. The equations of 4 lines are given. Identify perpendicular lines. How do I know if 2 lines are perpendicular? What do I know about the slopes? They're not just reciprocal. They're opposite reciprocal slopes. So, looking through here, what kind of line is y equals -2? We just answered this question. Horizontal line. So, what type of line is perpendicular to a horizontal line? A vertical line. So, do we see any vertical lines being represented here? Where? Line 3. So those 2 lines are perpendicular. Now, what we want to test is we want to see if line 4 is perpendicular to line 2. Okay? Now, what is the slope of line 2? Nope. No. What is the slope of line 2? 1/3. So what would be the reciprocal slope? What would be the opposite reciprocal slope to 1/3? Close. I heard 3, but that's not quite correct. Opposite reciprocal, -3. So what we want to see in 4 is, does this equal -3? Y plus 2 equals -3x minus 2. Get this. So we're going to get y plus 2 equals negative 3x plus 6. We're going to subtract 2. We got y equals negative 3x plus 4. Is that the opposite reciprocal slope? So 1/3. Yes, it is. More like game show music. They've won. Tell them what they won, Johnny. Nothing. Just they know how to do it now. Pat's 5 flower pots. Congratulations. Pat has won 5 flower pots. She wants to plant different types of flowers in each one. There are 7 types of flowers available at the garden shop. How many different ways can she choose the flowers? Can we solve this? The builder says, yes, we can. Okay. She wants to plant a different type of flower in each one. There are 7 different types of flowers available. What we want to do is we know that we only have 1, 2, 3, 4, 5 flower pots. There they are. How many different types of flowers could I plant in flower pot number 1? 7. Thank you. Now that I've planted a type of flower in pot number 1, how many different types of flowers can I plant in pot number 2? 6. Thank you. And then next. 5, 4, 3. Stop! All right, now what do I want to do with 7, 6, 5, 4, and 3? We want to multiply those on up. Somebody tell me what 7 times 6 times 5 times 4 times 3 equals. Right. I don't know. This is question number 20. Question number 20. Did I do that wrong? Finding permutations and combinations. There's 5 flower pots. We're playing different type of flower. Each one there's 7 types of flowers. It starts up 7 different ways. So you choose the flowers. Well, they're saying the answer is a paltry 21. No way. All right, what is 7 times 6 times 5 times 4 times 3? I think I disagree with their answer here. 2,520 ways. If there are 5 flower pots and 7 different types of flowers available at the garden shop, how many different ways? Yeah, that has to be the answer. It's 2,520. I disagree wholeheartedly with 21. The audience goes, ooh. That's when the answer key is wrong. 21 is full of 8 groups, much like a group of 10. Easy. Only one member team to go to the state championship. How many ways can the group be chosen? I got 10 different ones. Okay, you can have 10 different ones. Wrong here. 36, 22. Can't you have 10 different ones? Well, you're absolutely right. 39,916,000. If we have 10, and there are 11 people that could go. Oh, I think I understand here. Okay, let's go back up to that earlier question. Because we're only eliminating on question number 20. We're only leaving 3 out, right? So, real quick, what time are we're out of here? I'm going to go back. I'm going to end up stopping things right here, and I'm going to go back, and I'm going to do a video for number 20 and 21 and on down through there. So I'm going to redo those. So if you're watching right now, you want to go back, and you want to stop at question number 19, and you want to move on to video number 3, where we will pick it up next episode.